I am going to summarize the steps of muscle contraction. So muscle contraction starts with an electrical impulse from the brain to the muscle. It's called an action potential. It travels down a motor neuron to the axon terminal, which is the end of the motor neuron. The axon terminal rests above the muscle, and on the muscle is what we call a motor end plate. But the axon terminal and the motor end plate do not touch. There's a gap between them, and it's called the synaptic cleft. So that AP is going to travel down the motor neuron, reach the terminal, and once it does, it's going to cause vesicles that contain acetylcholine in the terminal to rupture into the synaptic cleft. The ACH will then bind to receptors on the motor end plate, changing them into ion channels. So the receptors are proteins, and they'll change to open, allowing sodium to enter and potassium to leave. More sodium is going to enter than potassium leaving. So this is going to change the membrane potential, causing depolarization, also called end plate potential. Then this will cause action potential in the sarcolemma, which will then travel down a T-tubule and gives the message to the sarcoplasmic reticulum, which in a muscle cell is the smooth ER, to release the stored calcium ions that it has. So the calcium ions are important for muscle contraction because inside the muscle we've got thick filaments and thin filaments. So our thick filament is covered in globular heads called myosin heads, and then our thin filament, which is called actin, has myosin head binding sites, but they are covered by troponin and tropomyosin, keeping them from binding. So we've got our thick filament, and then our thin filament kind of rests off to the edge of each side of those thick filaments. So that calcium releases, and the troponin is very attracted to the calcium ions. So they reach out basically to attach themselves to the calcium, which moves the tropomyosin up out of the way of the binding sites, creating the opening for the myosin heads to attach. Now, for them to be able to attach, we're going to need them to be energized. So we know that ATP is energy. So the globular heads usually rest at an angle. The ATP will come and attach to the globular head, causing it to enter the cocked position when it becomes energized. So it will stand more up. The ATP will be used up and turned into ADP and a phosphate. The myosin head will attach to the binding site, and the ADP and the phosphate will detach. So when that detachment happens, and when the myosin head connects, that's what we call the cross bridge. So when the ADP and the phosphate detach, the myosin head is going to go back to its more bent state, less energized state, which causes the contraction. So it causes the thin filament and the thick filament, the thick filament to pull the thin filament forward. Now it won't just attach by itself. So it's going to need another ATP. So another ATP will come and attach to the myosin head, and this will cause the release of the myosin head. So this happens over and over and over and over again.